Alright, continuing the welding operations 2 AIPD course, figure 1 an inert gas metal arc welding electrode holder. Direct current welding, indirect welding. In direct current welding, the welding direct welding current may be hooked up to either the straight polarity, direct current straight polar, reverse polarity. The direct current straight polarity machine connects the electrode to negative workpiece with as shown in figure 2 view A1 on the following page. The electron. Figure view 2 shows the current polarity and effects. Straight polarity, deep penetrations, and reverse polarity, shallow, wide weld. Reverse polarity view A, and straight polarity. Flow in the circuit is flowing for the connection with the electrode to the workpiece base metal with the plate with the direct reverse polarity. The welding machine connects the electrode positive with the workpiece negative. Workpiece negative is shown in figure 2VA with electron flow. When the circuit is flowing, the workpiece with the electrode straight polarity welding electrons hitting the plate at the high velocity exert a considerable heating effect of the plate, and reverse polarity of the welding on the opposite of the curve of the electrode will occur with the extra high heat which tends to melt out the end of the electrode, thus giving the amount of welding current of each direct current. Reverse polarity requires a large diameter electrode with a direct current, so the straight polarity, for example, the 1/16 of an inch diameter pentungsten electrode can be handle 125 amp of the welding current under straight polarity conditions, but if the amount of the current is reversed, it would melt the electrode and contaminate the welded metal. At 1/4 inch of the diameter pure with the tungsten large, however, can handle the amount of the current satisfactorily safely, while the heavy coated electrode, the composition coating with the gases produced the alter the heat condition producing greater than on the negative side of the arc. One type of the coating may be provided with the desirable heat balance for the straight polarity, with another type of the coating on the same electrode with the provide desirable heat balance with reverse polarity. These opposite heating effects influence not only the welding action but also the shape of the weld obtained. For example, the direct current straight polarity welding produces the narrow deep of the weld as shown in figure 2 view B1 of the previous page. Because of the large electrode of the low current that generally with the direct current reverse polarity welding gives a wide relatively shallow weld as shown in figure 2 view B2. One of the other effects of the direct current reverse polarity welding should be considered the highly here namely so-called cleaning effect that seems to occur, but although the effect of the reason surface cleaning action not known, it seems preferably and probably either the electron leaving the plate of the gas ion striking the plate intending to break up the surface oxide scale and dirt usually present. In general, straight polarity with the mild steel bare thin coated electron reverse polarity, but is used welding such as non-ferrous metal with aluminum, bronze, and model nickel. And reverse polarity is also used sometimes electrode for vertical overhead welds. The proper polarity of an electrode can be recognized by the shape. A sharp cracking around the arc with the wrong polarity will cause the arc to emit hissing sound, but the welding bead will be difficult to control. 3. Alternating current welding theoretically combined with the direct current straight polarity and direct current reverse polarity welding. They can be the best explained shown with the 3 current wave that's shown in figure 3 view A with the following page as each of the complete alternating current cycle. The deep is the direct current straight polarity and other half the direct current reverse polarity. Moisture, oxide scales, etc. on the surface of the plate tend to prevent the hair partially complete with the flow of the current with the reverse polarity direction. This is called rectification. For example, the no current flowed with the reverse polarity direction from the current wave with the weld would also look something like shown in figure view 3B. To prevent rectification occurring with the common practice to introduce an additional high voltage, high frequency, lower polar power current with the wind to the welding current. The high frequency current jump with the gap between the electrode workpiece pieces of the oxide film, therefore finding path of the welding current with the flow with the superimposed highly voltage high frequency current for the welding and current give the following advantages. The arc may be started without touching the electrode of the workpiece. 2. The better arc stability obtained. 3. The longer arc with the possible, the practical, useful surfacing hard facing operation. 4. Electrode has a longer life. 5. The use of the welding current range of the specific diameter electrode is possible. 5. Welding contour. A typical welding contour produces the procedure of the high frequency stabilized alternating current shown in figure view 3, view C1, and but a direct current, straight polarity, direct current, reverse polarity welds are shown in figure 3, view C2 and 3 for the comparison penetration contract and the arc AC and DC welds. Figure 3 shows the AC rectified AC wave comparison of the weld ranks. AC welding direct current straight polarity, direct current reverse polarity. View A, direct current straight polarity, amps and times, direct current reverse polarity, one complete cycle of the AC. And view B, amps, time, and a 2 complete cycle of the rectified AC. Filler rod. Sometimes enough amp metal to provide with the design joint form of the welded bead. However, the filler metal edge jab, the bare rod, with the handling freeing of the bolt from and the form of the coil wire automatically economically feeding the filler rod during the welding. Heat joint design, generally the type of the welding joints that we use in the tungsten and air gas welding operation. 5 basic types: the joint butt lap at the corner edge of the T that are used in other welding process almost. Any TIG welding will be with one combination, 2 or more of the 5 basic types. The selection of the proper design for the particular application depending on the primary flowing factors, physical properties desired for the weld type of the metal being welded, the size and shape, appearance, the assembly of the weld, filler metal in a form of the welding rod not needed to be used with the proper reinforcement, complete fusion edges that can be attained without the joints described in less than about or but a few many of the successful tungsten and air gas welding. They do, however, represent mostly frequently used. Many of the variations of these types can be used with the fully special job requirements. 2. Cleaning. Proper cleaning of the workpiece prior to the welding essential for the weld's good appearance, physical properties to be obtained. Are small assembly manual cleaning of the wire, brush, steel, wool, chemical solvent, usually sufficient for large assembly cleaning of the production base of the vapor. The decreasing tank cleaning may be more economically. In any case, be sure for the complete removal of all oxide, scale, oil, grease, dirt, rust, and other foreign matter from the work surface. Square butt joint. Figure 4 with the view A with the following page. The square butt joint with the easiest prepared can be welded without filler metal, depending on the thickness of the base metal being welded. The joint fitted up with the type of the joint should always be true enough to assure 100% of the penetration and in good fusion with a welding light gauge material without adding filler metal. Extreme care should be taken to avoid low spots of the burning through. The heavier thickness will generally require filler metal to provide adequate reinforcement. Sleeve single V butt joint. The single V butt joint used for the complete penetration required with the material thickness ranging from a quarter to 3/8 inch. Filler rod must be used and being included in angle V, but it should be approximately 60 degrees. The nose of the measure for the 1/8 to 1/4 inch, depending on the composition and thickness of the base metal being welded. Figure 4 shows the butt joints. Double V butt joint. The double V butt joint is generally with a 1 stock 1/2 inch and up where the design assembly being welded permits access as the back of the joint for the second pass with the type of the joint and proper the welding technique. The sure of the good sound weld is 100% fusion. Lap joint. Figure 4 view C of the previous page. Lap joint is advantage to limiting the need for the edge preparation. The only requirement of making the good lap the weld is the plate is to be enclosed with the contact along with the entire length of the joint and to be welded on more material 1/4 of an inch or less thickness of the lap joints can be made with or without filler rod. No filler rod used, but the care must be taken to avoid low spots and burn through. The lap type of the joint is not usually recommended material thickness than 1/4, except the rough fit up when used. The filler rod must always be used to ensure the good fusion build up and the number of the passes required depending on thickness of the piece of the base metal being joined. 5. Corner joint. Figure 5 of the view A of the following page. Corner joints are frequently used with the fabrication panel, pane boxes, and all types of containers as well. But the other heavier purpose the number of the passes required depending on the size of the V, the thickness of the base metal, and all other corner joints. Be sure that the piece of the good contact along with the entire edge. The edge joint. Figure 5 view B. Edge of the joints are slowly joint like light gauge metals can be welded without use of the filler metal. So since no filler rod metal is required, penetration is simple and the joint is economically welded. R7T. All T joints required additional filler rod to provide necessary buildup of the metal between the workpiece for the base metal with the welded number of the pads for each of the side of the joint depending on the thickness of the base metal with the material being welded with the side of the welding desired. The 100% penetration required, but to be sure that the welding current values are adequate thickness for the base and equipment. The basement equipment required for the manual tungsten and air gas welding is shown in view A. Figure 6. Consistently welding torch, electrical power supply, shielding gas, water supply, safety equipment should be used protecting against arc rays during the welding operation. Figure 5 shows the corner edge and T joints. 2. Argon gas is supplied with a steel cylinder containing approximately 330 cubic feet of the pressure of the 2,000 psi pounds per square inch. Single two-stage regulator may be used to control the gas flow. Specially designed regulator containing the flow meter shown in view B of the figure 6 of the following page may be used with the advantage of the flow meter to provide better gas flow. Control the flow meters calibrated with the cubic feet per hour with the current flow of the argon of the torch. The set of the turning adjusting screw of the regulator. The rate of flow depends on the kind of thickness of the metal to be welded. 2. The blanket and welding area provided with the steady flow with argon ice directed with the welding torch on page 7 on page 21. Since argon is somewhat heavier than the air, it pushes with the lighter air molecules aside with described in paragraph 3a on the page 5, thereby affecting the preventing oxidization of the welding electrode. Molten welded pool heat affected zone adjacent with the welded B. The tremendous heat of the arc of the high current usually necessity water cooling of the torch is shown in figure 7. The water circulated through the passage of the torch cool the torch. The electrode power capable to handle any of the torch for the cooling water, however, that must be cleaned to prevent blocking and passaging of the may overheat the damage to the torch. Staining and filtering of the water. This source is recommended for the cleaning of the foreign matter with the might clog using the up on the welding torch. Since intermediate direct support IDS or intermediate general support IGS fields are not always proximately public water source potable self-contained water cooling system are available to field use. Portable systems consist of the water storage tank with circulating pump. If such a system is used, the recommended with the antifreeze being the water during the winter months to prevent it from seizing. Further water pressure, some tungsten inert gas welding systems must be regulated less than 55 psi. Therefore, water pressure regulator is required. The type of water pressure regulator to be used for each tungsten inert gas welding system specified pertaining to the operator's equipment operator's manual. Figure 6 shows the gas tungsten arc welding equipment. Pressure gauge, flow meter, torch, cable operator, torch cable, water outlet, argon hose, welding cable, welding inlet cable, water supply, power supply, argon gas supply. Torch nomenclature. 1. The cap is made with the plastic shield with the tungsten electrode to prevent the escape of the gas from the top of the torch. Also, the locks for the electrode in place. 2. The collet. Collet is made of copper. The electrode is filled inside with the collet with the cap and tightened with the collet squeezed against the electrode, locking the electrode in place. Alright, this shows the TIG welding torch. Alright, gas orifice nut. The gas orifice nut allows the gas to escape out of the torch with the gas flow valve not shown in figure 7 on the previous page is open. 4. Gas nozzle. The gas nozzle directs the field, showing the gas on the welding pool. The top of the nozzle is used for the one light-duty welding is made with the ceramic material. One of the heavy-duty welding is water-cooled copper nozzle. 5. The torch handle. The torch handle is made of plastic reduced to change with the grounding the torch. 6. The hose. The 3 plastic hoses connected inside the torch handle carry the water gas. The accommodated electric power cable. The electric power cable is located inside the water drain line. This allows the cable to stay cool while carrying high ampere current. Starting the arc, figure 8 on the next page. Alternating current with the electrode does not have to touch with the workpiece to start the does not have to touch the workpiece to start the arc. Superimpose high frequency currents jump in the gap between the welding electrode and the work of establishing the path of the welding current with the flow of the strike arc of the first. Turn the power supply, holding the torch in horizontal position about 2 inches above the workpiece for the start block is shown in figure 8 of the view. The quickly swinging of the end of the torch down toward the workpiece so that the end of the electrode is about 1/8 of the inch above the plate is shown in figure 8 of the view. 8. The arc will then strike some alternating current welding machine's electrode must be monetarily touched plate with the wood drawn 1/8 of an inch before the arc will start. The downward motion should be made rapidly to provide maximum amount of gas protection of the welding zone when welding aluminum initial arc struck on the starting block to heat the electrode when the arc is then broken and reignited into the welded joint. 2. Direct current. When using direct current with the same motion of use the striking with the arc and alternate current. In the case, however, the electrode must touch the workpiece in order for the arc to start as soon as the arc is struck. Figure 6 shows starting the arc, the starting of the swing with a swing of the swing and an end of the swing. Withdraw electrode approximately 1/8 of an inch above the workpiece of the void contamination electrode with the molten pool. 1. Welding technique. Additional arc can be struck with the start with the blocking heat with electrode. The start block can be heavy piece for the copper or scrap of the piece sealed designing for the carbon block with the starting the arc. As the electrode becomes contaminated, causing the arc to wander with what becomes difficult to control after. Striking the arc on the starting block, the arc broken and reignited with the welded joint. The technique reduces the tendency of the tungsten inclusion to occur with the start of the weld. When starting to weld, the hot electrode rapidly moves the torch with the welding position becomes the arc tends to strike before the torch with the proper welding position. To stop the arc with the snap torch quickly back to the horizontal position. The motion must be made rapidly so that the arc will not may damage the welding surface of the workpiece. Keep the arc short with the same length of the diameter of the tungsten electrode being used. The short arc is essential to obtain sufficient and penetrating from the weld, and base metal also prevents undercutting the excessive widening of the weld bead, which results in the loss of penetration control and welded contour. In addition, for the short arc, ensure the inert gas completely shields or surrounded with the welding being formed. Establishing the suitability welded pool. Important with the welding must be proceeded to the head with the puddle after the molten pool formed forms most steadily along the seam of the gun tungsten position at an angle of between 60 and 90 degrees for the plate. It should be positioned pointed directly onto the filler rod. Filler rod metal may be added to the front of the leading edge of the pool, but one side of the center line of the both hands are moved in unison with a slight bleed back forward motion along the joint. The tungsten electrode should not touch the filler rod. End of the filler rod should not be withdrawn by the argon shield. For thick sections which require multiple passes of the form, a suitable bead are best welded with an air gas shield with arc using consuming a wool electrode section of moderate thickness between 1/16 and 3/16 of an inch can be welded to any of the commercial process available. Resistant spot seam welding is usually successful on metals up to 3/16 of an inch. Metal piece with 1/2 of an inch thick may be also spot welded. When arc is broken, shrinkage cracks may occur with the welded crater resulting in defective weld. The defective can be prevented by gradually lengthening the arc weld for adding the filler metal to the crater, quickly breaking and restriking the arc several times, adding some additional filler metal into the crater by using the foot control, reduce the current at the end of the weld. Tagging before the welding help with controlled distortion. Tack welds should be aimable size. Strength should be chipped out with the tampered end of the weld over. 5. Metal inert gas arc welding. Generally, the welding process is relatively new, only recently has been adopted by the U.S. Army in the field. Much use for the welding process will be made with the repair of aluminum hull track vehicles. Gas metal arc welding are MIG welding process in which the consumable bare wire electrode is fed into the weld at a controlled rate speed. A blanket of inert gas argon aluminum mixture of the two used in TIG welding shield with the welding zone of contamination. The process procedure high welds without use of flux and necessary for the post cleaning of the weld. Or the metal inert gas welding unit is designed for the manual welding and with a small diameter with a wire electrode with a using spool on gun torch with the shown figure 9 with the following page of the MIG welding system. This was well located away from the torch gun, but the principal operation was the same. And for the type of the system discussed here, the complete system with the consisting of the torch voltage control box, a welding contactor shown on figure page 10 of the page 29. The torch handle contains a complete motor gear reduction unit that pulls the welding wire electrode from 4-inch diameter spools containing 1 pound of wire electrode mounted in the rear of the torch. 3 basic size for the electrode may be either 332s and 364s and 1/16 of an inch. The type of the metal may be welded provided with the welding wire electrode in the same composition base metal. The unit was designed with the use of the AC/DC conventional constant current type of the welding power supply. This means that they are gasoline engine driven. Alright, MIG welding torch, figure 9. Arc welding machines issued with the field unit may be used for the power source of the welding serve. The MIG welding equipment components contact tube. The tube is made with a copper the hole of 1/100 to 200 inch large electrode. Contact tube with the guide of the bushing must be charged with the changing side of the electrode. Electrical power transmitted through the contact tube. Electrode insulated lock screw secure with the contact tube of the torch. Nozzle holder. The nozzle is made with a copper dissipate heat chromium plated reflecting heat. With the holder is made with a stainless steel and connected with the insulation material, which prevents the arc from being between the nozzle and ground. In the case of the gun comes in contact with the work inlet outlet gun guided bushings. Bushings are made with a nylon long where they must be changed to suit the wire electrode size when the electrode size is changed. 4. Pressure roll assembly. This smoother roller under pressure and spring tension pushes the wire electrode against the feet, allows the wire to pull the bolt from the spool of the thumb screw. Apply the tension as required. 5. The motor. When an inch button to depress the current with the running of the motor comes to the 110 volt AC/DC source. The motor pulls the wire electrode with the spool as required. Ready to feed the current with the motor is supplied with the welding generator. 6. The spool enclosure assembly. This assembly is made of plastic which prevents the spatter with the jamming the wire electrode with the spool. Small windows apply operating with the visual check for the amount of the wire electrode remaining on the spool. No, if any of the reason why the wire electrode stops, the feeding of the burn back will result. The trigger will be depressed with the welding contactor closed, allowing the welding current to flow with the contact of the tube as well as the wire electrode advances through the tube. The arc will be drawn by the end of the wire electrode. However, the wire electrode stops feeding while the trigger is still being depressed. The arc will then form an end of the contact tube, causing it to melt off. The last action is called a burn back. 7. Welding contact. The positive cable for the DC generator is connected with the cable component of the welding contactor with the ground cable connecting the welder workpiece with the electrode cable. This welding contactor cable are connected. Between the welding contactor, the voltage control box with the electrode cable, enter the welding current relay contact for the argon supply both, then go out of the voltage control box into the torch, and it is one line. Or argon gas hole, the hose is connected with the voltage control box, the argon gas regulator of the argon cylinder. 9. The voltage pickup of the cable. The cable must be attached with the ground cable, the piece of the workpiece for the service to supply with the current needed to operate the motor feeding with the wire electrode through the torch. 10. The torch switch for the ground cable. The torch switch for the cable. The torch switch cable is connected with the voltage control box. The torch ground cable is connected to the case with the voltage control box. The complete MIG welding system is shown figure 10 with the following page. C. Operating MIG torch. Starting weld to operate the torch. Start pressing the inch with the button into the torch handle to permit the wire electrode to merge with the nozzle. The wire should extend with 1/2 of the inch and beyond the end of the nozzle. While the main line switching the on position, the argon gas power sources adjust properly operated being welded. 2. If the welding open air with the protective screen must be installed to prevent the argon gas from being blown down away from the welding zone. Pressure with the torch trigger permits the current flow through the torch switch cable through the contactor cable. Close contactor 4. The contactor closed with the welding circuit with the generator. The welding torch is complete. 5. At the same time, the contactor closes the shielding gas solenoid valves open, allowing the flow of argon gas to mass out of the nozzle shield of the welded zone. Alright, figure 10 shows the MIG welding system. Alright, lower welding helmet touching the end of the wire electrode workpiece. The gun is held at a 90-degree angle with the work point at a 100 angle toward the line of the travel. The welding will continue along with the arc that is maintained with the trigger is depressed. Caution, prevent overloading the torch motor when stopping the arc. Release the trigger. Never snap the arc out or raise the torch without reverse releasing the trigger. Desetting the wire electrode feed. A dial on the front of the voltage control labeled welding control is used to regulate the speed of the wire electrode feed. 2. They increase the speed of the wire electrode being fed with a spool. Turn down the L counterclockwise. This decreases the amount of the resistance across the arc or the left of the motor to return faster. Turning the dial clockwise will increase the amount of the resistance, thereby decreasing the speed of the wire electrode being fed from the spool. 3. At the ends of the wire electrode touch with the workpiece between the 50 and 100 volt direct current generator. The voltage is picked up with the high voltage pickup of the cable to shun back of the voltage control box into the transformer. The transformer steps down the voltage 24 volts direct remember the operation from the torch motor. 8. Fuses. 2. 10 ampere fuses located in the front of the voltage control box protect the control of the electrical circuit within the voltage control box. 2. 1 ampere fuse located with the front of the voltage control box protects the control of the torch motor. Installing wire electrode. We'll open the cover of the spool enclosure with the brake of the pressure of the roll assembly shown in figure 9 on page 26. Unroll the straightened 6 inches of the wire electrode on top of the spool. Feed the straightened end of the wire electrode from the inlet outlet bushings placed the spool on the mounting shaft. Close the pressure roll, secure it in place, press the inch button, feeding the electrode until there is 1/2 of the inch protruding beyond the end of the nozzle. Setting up the argon pressure. Flip the argon switch in the front of the voltage control panel with the manual position. Turn the argon cylinder valve to set the pressure on the regulator. When the proper pressure is set on the regulator, flip the argon switch to the automatic position. When the argon switch is placed in the manual position, the argon gas continues to flow until the turn off the valve when in the automatic position. The argon gas flows only with the torch trigger is depressed and the stop flowing when the torch trigger is released. 8. Generator polarity. In proper operation, the torch motor of the generator must be set on reverse polarity. If the generator is set on the straight polarity, the torch motor will run in the reverse, withdrawing the wire electrode from the torch gun and causing the severe burn back over the torch. Reclaiming burn back contact tubes. When contact tubes are new, they are 5 3/8 inches long. The burning back occurs with a minimum of 3/8 inch may be filled off with a file with a flat spot on the top of the guide tube. The use of the appropriate size and drill pilot. Drill out in contact tube with the example of the 3/64 inch of the contact tube using the number 4647 drill bit. Alright, J. Welding operations. Any fused, non-fused metal can be welded through the use of the MIG welding process. The hard welded metals, such as aluminum, magnesium, titanium, must be welded either by the MIG or TIG welding processes. MIG welding process use the filler rod, the use of the welding thicker metal, particularly with the thick aluminum. The TIG welding process, the use of the welding thinner metal with or without use of the filler rod. Penetration of the metal and the type of the joints used for the MIG welding operation are the same as the modification 5 basic joints discussed in paragraph 4G, beginning on page 14. A more detailed discussion of the 5 basic joints is contained in Technical Manual 9237. Conclusion. The tasks described in the principal operation equipment and nomenclature safety precautions pertaining to the tungsten inert gas metal arc welding process. There are two newly developed welding processes that have recently been adopted used for the Army field and field. The next task describes the procedure of troubleshooting and repairing welding equipment. Lesson 1, inert welding, safety precautions, inert gas welding principles, safety precaution, gas metal welding principle, operation equipment, nomenclature, procedure, troubleshooting welding equipment, and determining methods of repair. We're on 94.